Now recording. So, hello and welcome to the second half of Server Side. I hope that we can have a wonderful, beautiful second half. So, in terms of housekeeping details, you may notice that I am not Professor Adams. Professor Adams is now on vacation and is likely to be relatively unresponsive to communication. He's told me that he's kind of going to be around a bit, but that, he is on vacation. So if you have any questions, queries about the course or anything, please direct them to me rather than to Professor Adams at this point, and I'll be able to direct you appropriately. So if you've never had a class with me before, it is my habit to video record these lessons. I then post these to YouTube, my YouTube channel, after the lesson has been complete. Normally it takes me, hopefully no more than half a week to actually sit down and upload the videos. So if you have to miss a class for whatever reason, the YouTube channel is there. If you prefer these sorts of things with captioning, YouTube also does captioning on the videos, so that's also for you. It doesn't mean don't come to class. You still have to come to class. Class is still the best way to learn. If you want to pass, come to class. In particular, class is the highest bandwidth of information that you're going to get from me. It's nice. It's nice that we have all of this technology now, but how big is this? How big is the video on YouTube? Like that big? Wouldn't you rather have all this? But also, if you're watching all of the lessons in post, you don't get the opportunity to ask questions during the lesson. I do respond to comments asking questions on the YouTube videos, as I catch them, I also, if you have technical questions relating to the material, I'm also happy to answer by email. I understand that Professor Adams really likes the forum that's built into Canvas. I will do my best to keep on top of that, but that's kind of like not in my usual workflow, so if I'm a little less responsive on that, it's not because I'm ignoring you. It's just because I hardly use the thing. Any questions so far? Yes, sir.
What's your YouTube handle?
Sorry?
What's your YouTube handle?
Oh, I can never remember. I'll just show you. I'll post the link to the channel in the announcements feed. But if you just search Nick Moore Mohawk, there I am right there. I'm this guy, not that guy. You might be able to tell because, as you can see, I am not wearing a ball cap, and it is not in the backward position. So, but yeah, this is the YouTube channel. The videos are typically organized into very helpful playlists according to all of the courses I teach. You can see I've been doing this for a while. If you're terribly, terribly interested, you can go back into the back catalog of offerings of this course that I've done in previous semesters, and you can sort of watch forward in the class a little bit if you have a little extra time. Extra time. Yeah, as if anybody has that, right? So, any questions? There's also a playlist of pointless nonsense, which I don't recommend. Any questions about any of that so far? Doing good? Good. So yeah, that's more or less the long and the short of it. There's some material in there from when I was working at McMaster University as well, if you're interested in some more advanced computer science related material, but enough of me plugging the YouTube channel on the YouTube channel. It's a tool it's a tool that's good for studying. If you need to review a concept, before the exam or something like that, you can actually watch the actual lesson, even at 2 times speed. Yeah. So when I was talking to Professor Adams during our sort of handoff meeting, there were 2 things that he kind of indicated to me as being important. One, he thought that it would be a good place to pick back up with sessions. He said he touched on sessions before the break, but that probably you guys need a review of it at least, and probably a chunky review at that. I'm happy to pick, I see a lot of nodding heads, so that will be what we do. We'll start in at sessions. Yes?
Can I also do a bit of cookies? I feel like we can cover that just some berries like
Oh yeah, sure. Yeah, we can do cookies as well. I didn't bring cookies, but yeah, we can talk about cookies, absolutely. I also have a couple of, well, maybe we'll get in, there's a bit later on we get into like passwords, like very vaguely, and I have a couple of nice YouTube videos that I like to show with respect to that, but that's probably not this week. Yes, sessions and cookies, sounds good. The other thing that Professor Adams indicated to me was that the grades on the midterm were somewhat less than stellar. I am hoping that we can pull our socks up for the exam and get everybody through the exam. Given that it seems a fair number of people came somewhat not quite to the point of passing, shall we say, on the midterm, perhaps it would be useful to review the policy for this course with respect to what are the requirements to pass the course. There is a requirement in this course that the testing component be passed in order to pass the course. The reason this policy exists is basically because, like it or not, assignments don't necessarily demonstrate that you understand or know anything anymore. This has been a problem that has existed far predating recent advances in generative AI. It's been true for quite some time that you can basically cobble an assignment together with too much help from the internet, and that the code will basically work because all I can give you is a school assignment, right? This is a school. All I can give, the scope of the thing I can give you to do in 2 weeks is something that you have to be able to do in 2 weeks, right? So once you get out into the actual industry, you will not be working on projects that only take 2 weeks, right? So once you get out there, you have to work on stuff that's a little chunkier, right? And although to what extent AI will completely make your job redundant is an open question at the moment, I believe. I must, as a member of this institution, I credential people, not algorithms, right? In order for you to get through this class, I must know that you have a certain amount of information about this in this little fancy meat computer, right? So that's the impetus behind the policy that you have to pass the tests, right? Now, the manner in which you have to pass the tests is a little more forgiving than people get the impression of. So the policy is that you must pass the test and the exam in combination. It's not that you must pass both of them. And it's also not that you must pass one or the other, right? It's not a logical operation. It's an average operation. your average grade between the two, taking into account their weights, must be above 50%. So, the way that you can think about this, if you didn't pass the midterm, you must pass the exam by however much you failed the midterm by. That's the sort of mathematical effect. So, if you came really close, if you got like your, 47%, 48%, then you only need a 52 or a 53% on the exam in order to meet that requirement. However, if you're in a situation where you got 30% on the midterm, then you're in a situation where you need to get those extra 20% on the final exam. So basically, take however much you failed by, double it, and that's how much you have to pass. That's the gap that you have to make up, right? Now, the bigger that gap is, the harder that will be, obviously, right? So basically, the more you are in the hole right now, the more you need to be prioritizing this class for studying, right? Does that make sense? Does anybody have any questions about the policy? Okay, good. So that's how that is. All right, any questions in a more general sense? I think we're, I can't think of any other bookkeeping issues. If I think of anything else, I'll say it. Good. So, shall we get into the material then? Wonderful. So let's talk about cookies. So, cookies then. Chocolate chip, peanut butter, and of course, white chip macadamia nut. No, we're talking about a different type of cookie today. So, what is a cookie? Does anybody have any idea?
I'm just trying to think of an analogy, but it's basically like a token that allows you to basically personalize a website, kind of?
Yes, a token that allows you to personalize a website. That's one use of cookies. It's actually increasingly not the most common use of cookies. But yes, it's a token of some sort that allows us to customize a website. Anybody else have any idea what a cookie is? Yes.
Something that saves information specific to like one user on a website?
Something that saves specific information specific to one user on a website. So, yes, that definition also covers sessions, though. And sessions and cookies are not quite the same thing. A session is most commonly implemented using a cookie. So cookies are the physical data that's being transferred around. Sessions are the thing that we use the cookies for most of the time. Does that make sense? So, what is a cookie then? Well, we must return once again to our client-server model. We have our client represented by an antiquated CRT monitor, and we have our server. As we know, who initiates communication?
So, client.
Client in all cases, that's right. So the client always initiates a request to the server. The server responds to the request, sending information, the requested information, back to the client. So far, so last semester. Here's the difference. Well, let me approach it this way. This is the problem that cookies are meant to solve, right? The server does not know from which client a request has come, right? HTTP is a stateless interaction, right? That means that the server, when it receives a request, it can't see this half of the diagram, right? It doesn't know who this client is. It cannot tell the difference between this or any of the other million clients that it might be communicating with, right? So this is a problem. It's a problem that we can't tell who the client is. For one thing, it makes login sessions very difficult to perform, right? When you're trying to do something with a login, right, you need to be able to identify a computer as being the same computer you were talking to previously, right? Otherwise, the effect of logging in would be to unlock your account for every computer on the internet, which of course is about the most undesirable thing I can possibly think of. So, how does the HTTP network protocol handle this problem? What is our solution? And the solution is the cookie. So, a cookie is a tiny packet of data which is included in the response that a server sends to a client. So, up to now, when we've been writing our PHP scripts and we've been responding to requests from a client, we've just been sending the response itself. We haven't been packaging any, you can think of it as a type of metadata, right? We haven't been packaging any sneaky hidden data, right? Well, now is the time to get sneaky. Sneaky cookies. So basically the cookie is a little packet of information that we send along with the response that the browser then stores, right? You can think of the browser as having a cookie jar. Awful cookie jar, but you get the idea. So, when the server sends a cookie, the client takes that cookie and drops it in its cookie jar. So it stores it in memory. So far so good? Any questions? Yes?
What's in the cookie?
Excellent question. It's a key value pair. So the actual data in the cookie itself is very similar to a get query or a post query, right? Like, I'm trying to remember assignment 2. Did Professor Adams run the one with the shopkeeper?
No.
No?
No,
Oh, he reverted, did he?
Yeah.
Yeah. So the let's say you send an HTTP GET request. Let's say you attach name equals Dr. Moore, right? That's a key value pair. The thing that's being sent, like the actual cookie itself, is also a key value pair. So, the thing that's sent back from the server could be something like name is equal to Dr. Moore. But, what do we never trust?
Client.
The client.
We never trust the client. That's right. Sending it raw textual data is a bad idea because you could be giving this cookie to, a Russian spy, for example, or, pick your bad actor. You could be sending your data to someone who's going to use that data to try to crack your server. So, what do we often send? Cryptographically secure strings. So how much do you guys know about cryptography? Little it? Eh?
Very little.
Very little?
Yeah.
You want a crash course? Crash course in cryptography?
Sure.
Yep.
Awesome. So that's the correct answer, by the way. So let's talk about how hard it is to guess a number, right? All cryptography hinges on the difficulty of guessing a specific number, right? So let's say that I have in my head a number between 1 and 10, right? How many tries do I need to guess that number at maximum?
10.
10, right, because there are 10 possibilities, right? So that's if I have one decimal digit, numbers 0 through 9, let's say, right? What if I have 4? How many possibilities are there?
10,000?
Right, because I've got 0 through 9999.
Assuming they're integers, not.
Assuming they're integers, yes, absolutely.
And they're real numbers.
Yes. We're, at the moment x can be any decimal digit, right? So, that's much better. That's much better than 10. Takes you longer to guess that. But for modern computer systems, that can still be cracked like that, right? You can guess what the secret number is very, very quickly. So, it turns out that there's a formula. For any particular digit, you are concerned with two values. The number of characters that that digit can be, and the number of characters in total, right? So the actual formula is, we've got 10 possibilities here, times 10 possibilities here, times 10 possibilities here, times 10 possibilities here, right? So the formula is the number of characters you're using, let's call that C, number of characters, to the power of the number of characters in the string. So you can make this number more difficult to guess by increasing either of these, right? So how do we increase C? Increasing C is way more powerful, by the way.
Do you have letters?
You add letters, absolutely. How many letters are there in the English alphabet?
Don't ask me that.
Anybody?
26.
26, yep. Uppercase, lowercase, right? So we've got 10 decimal digits, 26 lowercase, 26 uppercase. That's starting to get pretty up there. That's pretty good, right? Yes?
I just had a thought. So you know what, like loan words, how sometimes loan words keep like the original symbols, like jalapeno has the little and with the little symbol on top.
Ah, yes. So yes, you can get a lot further with cryptography. Like, ultimately, the number of bits that you use to represent these characters is what's actually at stake, right? So when you're talking about the extended Unicode character set, does anybody know how many bits are in standard Unicode per character?
I want to say 256.
Not nearly that many. Yeah. So does anybody know how many bits there are in standard ASCII? Anybody? So standard ASCII has 7 bits for reasons that are kind of silly, because standard ASCII was originally developed for electric typewriters, and that's why it's not like base 2 like everything should be. Extended ASCII is 8-bit. Extended ASCII is the same thing as Unicode 8-bit version, but standard Unicode is 16 bits per character, right? So it's a 2-byte word. So yes, if you're using Unicode and using extended Unicode characters, that's, you know, you're packing more information into characters in theory, but you're not necessarily packing more information in terms of bits, because a great deal of Unicode is unused. Only about 16,000 characters are defined in Unicode. So there's a quite, like most of the Unicode address space is unused and doesn't point to anything. So you're actually, it's actually less cryptographically secure to use Unicode versus 2 extended ASCII characters. But, you know, generally once we get this to about 80, like we don't really have to worry about it anyways. Let's throw another set of, like, you know, 10 miscellaneous characters, parentheses, octothorpe, ampersand, all of that stuff, right? So, once we get to this level, we have how many characters? 72? 72 possible characters. So then, we have to decide how long our string is going to be. 72 to the power of what? Ordinarily, you pick something that's also base 2, but let's just go for, let's say 32 characters. 72 to the power of 32. Now that's pretty big. That's quite large, right?
Yep.
If you enter that into Google, you'll probably get like, well, let's see. 72 to the power of 32. Sorry, I can't do that one in my head. So that is 2.72 times 10 to the power of 59. So that is 2.72 with 59 zeros after the decimal place. This is an extremely large number. So let's assume that we can test 1 billion of these per second, right? If we can test 1 billion of these a second, that we would need 2.72 times 10 to the 50th power, that many seconds to guarantee cracking that code. Now that's a pretty large number of seconds. I'll give you that in years, just give me a moment. Minutes, hours, days, 365.25, there you go. So the number of years that it would take to crack that code is 8.62 times 10 to the 42. And the age of the universe in years so far is, I think, something like 10 to the 14. So you would basically, you would have to take the entire time duration of the universe so far and multiply it by itself several times, and that's how much time it would take a brute force algorithm checking 1 billion possibilities a second to crack that code. And that's why cryptography works. Any questions about that? So, when you are deciding on your passwords for anything that you sign up for online, the absolute very best thing you can do is generate a random string of whatever the upper character limit is on whatever it is you're signing up for. Typically it's around 30. And just use a password manager so that you don't have to remember it. But if you do that, then your password will never be cracked. I mean, never with a great big asterisk on it that says, assuming quantum computing never exists. Oh, we've been 5 years out from quantum computing for the last 30 years, so, you know, maybe it will, maybe it won't. But this is the type of thing that we have to think about when we are sending people cookies. So the value of the cookie will, most of the time, be one of these things, a cryptographically secure string. For a number of reasons. Number one, it's just about impossible for a bad actor to get any useful information out of that string, right? Number two, it's almost impossible for you to guess someone else's. Number three, duplicating one is also, like duplicating one randomly is also almost impossible. Say, you were logged into Facebook and you were logged into Facebook. Despite all of the people on Facebook, the probability that two people are going to end up with the same session ID is astronomically low. So we can generate IDs for people using this method without having to check existing IDs to see if they are the same ID, because, it's an event that would happen, once in the duration of 100 million universes, right? So you don't really have to worry about it. That's the thing though, is it's still possible. It's one of those mathematical things where it's still possible for it to happen. It's just would you or any of your descendants likely see it? No. Right? So, even if they would have to invent immortality, and even then, so, any questions about any of that? So that's what the cookie typically contains. So, most of the time, what we use cookies for is identifying one client among all of the clients who are connecting to our server. So we will say something like ID is equal to 14 or something. Just take that and swap that out for one of those, right? So we say, okay, in our little bag of cookies, we now have ID equals 14. The server has tagged the client with this information, right? Okay. This is only half of the equation. The second half is, how does this information get back to the server? Anybody care to guess? I'll ask a previous question over again. Who initiates all communication? The client. So, however it happens, the client is the one who has to do it, right? So, the client must initiate a second request with the server. When it sends the second request, it sends, by default, without anybody having to ask for it, all of the cookies that apply to that server. So far this has been a simplified view of cookies. They have more data in them than just the actual key value pair. One of the pieces of information that a cookie stores is what domain the cookie was originally sent from, right? You've got, you can imagine your bag of cookies, if you're just throwing the cookies in willy-nilly, you don't know which server gave you which cookie. So each cookie also tells you which server gave you that cookie. So when the client initiates a request, it goes through its cookies. It says, that one's for this server, that one's for this server, that one's for this server. It takes those cookies, it packages them up into the request, and sends all of the cookies back to the server that the server originally sent. Make sense? The server then receives these cookies. One of these might be, for example, ID is equal to 14. And then the server, because it sees this cookie says, "Oh, you! Yes, I remember. You're the one who's has failed your login attempt 4 times, and I locked your account. Very good. Yes." So the server knows which client it's talking to only because this cookie was sent out. Right? Make sense?
Yep.
Good. Now it's time for never trust the client. Once again. Yes, question?
Does the client send it back at like normal intervals or just when you try to update something?
It only sends it attached to a request that was generated otherwise, right? So cookies don't, there's no set interval equivalent for cookies that runs automatically. The client is not by default in constant communication with the server. Now, if you wanted to do that with an AJAX request, that's something you could do, right? Basically, if you want that, you would build it in. But it doesn't do that by default. By default, it's just anytime any request is sent, by any means, it sends the cookie as well. Make sense?
And it sends every cookie you have at the time?
Every cookie filtered for this server's domain. Make sense? Any questions? Good. So yes, we send the ID back. The server can now recognize a client because it's sending back the ID that it sent to the client. At least that's how it's supposed to work. Never trust the client. The client, and this is very important principle, the client has the ability to modify everything the server sends it, right? You can do this with HTML, you can do this with CSS, you can do this with JavaScript, you can do this with cookies, right? Let me show you how. So let's say that we are in Canvas, heading to our inspector pane. This depends slightly on the browser that you're using. It's all generally in the same place, but if you're using Firefox, they keep the cookie access in a slightly different area. But this is how you do it on Chrome. If you go to the Application tab, you got cookies right here. Pull the drop down, and you can see that it is in the drop down filtering your cookies for the domain, right? So let's take a look at my canvas. Maybe increase the size there a little bit. And you can see a couple of things immediately. Number one, remember what I was saying about cryptographically secure strings? There you go. A bunch of random numbers. The names are a bit more understandable. Canvas session, for example. This is modifiable. There you go. You can see that that's now duplicated the cookie, probably because this website is communicating with the server and reset the cookie when I did that. So we can modify not only cookie names but cookie values. There you go. Now, having done this nasty deed, how is the server going to respond to this now? Well, it's getting the value that it expects, or it's getting the name it expects, but it's getting an invalid value now. So normally, the effect of this is to break the session, right? Typically, one of two things will happen. Either the session will just break, or the server will create a new session with this new session ID that it's found. Does that make sense? It depends a little bit on how you configure things. It's a bit more secure to just break this session if nothing, if you detect something like this going on. Does that make sense? So, okay, so you may be saying, but that seems like it's a possible security thing. Maybe we should consider countermeasures. Well, it turns out that there are actually there are things you can do. You can attach to the cookie. Oh look, a secure flag. The secure flag is set. That means it's secure, right? Oops. The client also has the ability to unset the secure flag. So if you think that the secure flag is making it secure, it's not. Another thing which is important, this flag, which is HTTP only. So one thing that you really don't want is you don't want somebody basically ganking your session ID using JavaScript, right? This flag, in theory, makes the cookie inaccessible from JavaScript. Guess what I'm about to do? Oops! Did I just make that accessible from JavaScript? So, there is no such thing as security on a client. This is why we're using cryptographically secure values. If you mess with it in any way, shape, or form, it no longer matches the value the server expects, thus breaking the session, which is good. Number two, I forget. What was I going to say? Anyway, yeah, it also solves the duplicated session IDs problem using these types of strings. Because, in order to guarantee that you're issuing a unique number, you need to, in theory, keep track of all of the numbers you've already issued. But of course, that's a problem that grows in size with the number of users that have ever logged into your system ever, right? So this is a much easier solution. Just use a big enough space that it practically doesn't matter. Right? Make sense? Any questions so far? Yes?
So every time the client responds, it checks the client's cookie values with the ones it generated to start?
Yes. Every time the server responds to a request, it receives the cookies, checks them to see what ID they correspond to, and then gets you the information corresponding to that ID. This is how a session works, right? We're gradually fading into sessions now, right? So in our example on the board here, right? The server sends a cookie value of 14. The client sends 14 back. In the back end on the server, you will have a thing called the session database. We're now talking about sessions, right? So the session database says, okay, I got the value of 14, that corresponds to some data. X is 7, Y is 14, etc. Just data, key value pairs, right? So it's actually fairly simple. When an ID cookie comes back, and the name here is usually PHP session ID or PHP sesh ID in all caps. The name isn't important. You can configure what the name is. When you receive the ID cookie back in the server does a very simple lookup in its database to say, okay, what's the data for that number, right? Say, okay, up 14, okay, load this data. Good, done and dusted. You then do stuff with that data, right? But let's assume that we have a nasty little user who has modified the value of the cookie. So it's not 14 that gets sent back, it's 17. When this cookie gets back to the session database, do I have an entry for 17?
No,
So what do I do?
break the session.
Yeah, that's not a session. I have no entry for that, that's not a session. And you are a wretched scallywag for sending me an invalid ID. Now, there are reasons that the ID could not be in here other than people going in and modifying them. One of the things that cookies do is expire, right? Cookies are time limited. So, you might imagine, maybe, this is a client that connected to this server, 7 months ago. It's coming back now with an ID that was issued 7 months ago, right? Well, the server will have deleted that by now, right? It's like that cookie was only good for 20 minutes. You're coming back to it. You're coming back to me now, 7 months later? Come on, right? So if it and this is one of the things the server does, is it routinely cleans up its session database for expired sessions, right? So 17 might have existed, no longer exists. That number's now free again. It can be reissued, except of course it's cryptographically secure, so the probability of the server ever using it again is extremely low. If that number comes back again, there is no entry in the database for it. It's been deleted, right? So again, this is a choice now. Depends on how the server is configured. Either you can consider this a request for a new session, which is the better and more secure way of doing this, or you can say, well, I'll just make you a new session with that ID, right? You don't want to do that. You don't want clients to be able to collaborate on what the session ID should be, right? So, one of the sort of prizes that a hacker is always after is your session ID cookie, right? Remember that the only reason that this server knows who you are is because you have the right cookie value. He still can't see you. And interestingly, he cannot tell the difference between two computers sharing a session ID. Doesn't know the difference. Incoming requests from 1 computer, 2 computer, 10 computers, it has no idea. Because everything is based on the cookie value. If this cookie value is shared by 10 computers, the server treats it the same way it treats 1 computer, right? So, if a hacker gets in, steals your session cookie, loads up a browser, loads your cookie, they have your active login session. And the immediate thing that they go to do is then change your password. if they can. Lock you out of your own session, lock you out of your own account. This is why a lot of the time websites will require you to re-enter your password, your username and password, or your password at least, if you're making any major account modifications like changing your password. Enter your existing password, enter your new password twice. The reason it does that is because if the session cookie has been stolen, the person who stole it probably doesn't even know your username and password, right? Probably doesn't have your password. So, if they don't have your password, they can't change it. Yes?
Is there a reason we can't add something like location to, well, preview, like if you give them consent to track your location, is there a reason you can't add location to cookies so you can like, say somebody across the halfway across the world stole your cookie? It's like you don't give them access because they're halfway across the world.
You can get a little ways with that, but it's not perfect, right? One of the ways that you typically do this is using, you can do this looking at the IP address, right, to a certain extent. It used to be actually, like, it used to be a fairly common security measure to kill a session if the IP address, if you're connecting from like 2 different IP addresses, right? Makes sense. That makes sense. Only problem, these stupid little things. Yeah, got you. These things. You want to know what happens every time you pass from one cell phone tower to another? You get a new IP address, folks. What happens when you go from one Wi-Fi router to another within the same building? You get a new IP address. So these things, their IP addresses are quite fluid. They change quite a lot. So we can no longer rely on IP addresses being constant as a security precaution, unfortunately. And unfortunately, most people are using these for all of their internet access these days, right? Gone are the days when everybody was using a good, solid machine with a keyboard. But the other problem is if you're a hacker and you're not using things like virtual private networks to spoof IP addresses, you're not a very good hacker, right? The game has moved several steps down that direction, and IP addresses, basically everything that the client is sending in the header can be modified anyways, right? It's let's say, for example, we don't even talk about IP addresses. We just put something in the header that says, I'm from Brazil, right? Or I'm from Canada, or I'm from Uzbekistan. Because it's in the request, you can just change it, right? If you're a hacker particularly. So it's you're fundamentally trusting the client to correctly report what country they're in, which they're not going to do if they're a hacker, right? So never trust the client. That's just the law. That's the law of the land. Never trust the client. Does that make sense?
Yep.
Cool. Shall we talk practicalities and actual code? I think we've, are there any more questions about sessions? Or the stuff, the theoretical aspect? You feel you have a pretty good understanding?
I think so.
You have a question?
I still want to know so most sessions are cookies, but cookies aren't sessions.
Let me come up with an analogy. All right. The statue you see in the park is made of bronze, but bronze is not the statue,
Okay.
right? So sessions are built using cookies. But cookies are a more general tool. They can be used for lots of things other than managing sessions. Fantastic example, bloody advertising, right? So I'll just give you the rough one because I'd like to move on to some PHP code, but this is how internet advertising works, right? It relies on third-party cookies, right? So basically, let's say that you are a website and you want to put a banner ad on two other different websites. A lot of you probably know that when you're doing internet advertising, you get paid for clicks. You might get paid for views, but mostly you'll get paid for clicks. Someone who clicks on that banner ad gives you like 0.003 cents, and it links them to the website being advertised, right? This is generally how it works. So, and by the way, this is why, when you're playing a game on your phone, like it used to be that like they didn't always take you to like the Google Play Store for that app, but now they almost always do. It's because that following that link is what they're getting paid for. That's like physically what they're getting paid for. So let's imagine that you're advertising on two websites, website A, website B. If you receive incoming traffic from your banner ad, how do you know which website sent you that customer? Cookies, right? Website A and website B will tag your computer with advertiser IDs, right? Advertiser 17, advertiser 21. If I get somebody coming in, they have a cookie, and the cookie says advertiser 17, that guy gets paid, right? Which is why they hate it when you disable third-party cookies, because it completely destroys all of their internet advertising. But it's, internet advertising is basically a monopoly between Google and Facebook anyways, though, so, good luck trying to get around those two. So, that's another use of cookies, right? It's different. There's no session being kept. Like, those IDs will correspond to some database somewhere, but it's a different mechanism than, like, the built-in session thing that we're about to use in PHP specifically. Does that make sense? So cookies are a more general tool. Sessions are specific to, certain applications, right? Most of the time when you're thinking sessions, you should be thinking login sessions, right? Not again, that's like another narrower but very useful subset of the things that sessions can do, right? Here's an example. Amazon, right? Amazon lets you fill your cart without having logged into anything. And then it only requires you to provide, or it doesn't even require it. It only asks you if you want to provide your Amazon login when you say, okay, checkout please, right? So the session is established as soon as you visit Amazon. It's in that session that you are storing your shopping cart, and then at the end, once you've selected all the stuff you want, then we decide if we want to validate the session. That's an important term, right? We have sessions, and then we have validated sessions. A validated session means they have given you some credentials, like a username and password. Those credentials check out, and now we can consider this session to be with an authenticated user, right? But we don't have to worry about that just yet. We'll get into that after we do databases. Make sense?
Mm-hmm.
So, let's do some actual gosh darn code. Question?
Yes. So I've seen websites that says, oh, this website gives cookies, and then they give you option at the bottom whether to accept or reject. Like, what does that mean like?
So there's a couple of interesting things about that. First, the only reason that they do that in the first place is because it's legally required in Europe. So it's not actually legally required in most jurisdictions, but the problem with the internet is basically when you design a website, you have to design it for the most restrictive set of laws on the earth. Because otherwise, you have to issue a different version of your website to Europe, a different version to North America, a different version to South America, a different version to, it becomes an increasingly complex problem. The easy solution is just, who's got the most restrictive laws, we'll make it for them, everybody else is going to have to deal with it. So that's why you see that pop up now, right? So normally, those pop-ups, they distinguish between necessary cookies and unnecessary cookies, right? The unnecessary ones, ordinarily, are advertising cookies, right? The necessary ones are things like managing your login session, right? So basically you're saying, I'd like to opt out of advertising, please. But, here's a question. Who's checking? Where's the internet police? Right? Where is the in theory, if they issue you an advertising cookie when you didn't ask for it, you could sue them in Europe. Are you a European? Do you have any grounds to sue anybody in Europe?
No.
Probably not. So, So, are people gonna find ways to get paid? Yeah. Right? Realistically speaking. It's getting to the point though that if you are a company that makes internet websites and you don't have a lawyer on staff, you probably should have a lawyer on staff, because that's kind of the way things are going these days. And if you were a little bit more conspiratorially minded, you would say something like the requirement to have a lawyer on staff is probably an intentional, it's a feature, not a bug of the system, because it prevents small websites from getting big, right? It's much harder to be a startup if you need to hire a lawyer, right? But that's all conspiracy theory nonsense. I'm sure that's not true. So, let's see here. Where was I? Yes, we were going to do some sessions. So, if everybody could please open up XAMPP, we will get some actual coding done. Now that I've said the word XAMPP and I've reminded myself about XAMPP, I have to tell you something about XAMPP, which if you didn't already know, this is quite a big security thing that actually affects you as students. So, have you noticed where XAMPP installs itself on these machines?
C drive.
Yeah, just the root directory. Do you know who has access to the root directory? Literally every logged in user. Every single one. Anybody who logs into these computers has access to that directory. If you are doing your assignments on these computers, delete your work when you leave. Okay? Because if you leave your work, if you leave your assignments kicking around on these computers, the next person who logs into them, even in long subsequent semesters, can see it, can yoink it, can get you charged with academic integrity. So just, because like the type of people who submit work that they found on a lab computer are not the type of people to modify it heavily before they submit it. They'll just submit it, right? So, so this is fair warning, okay? Right. Do not trust the client, and do not trust lab computers. Yeah, does everybody have like a removable hard drive that you keep your stuff on? Yeah. Like, I believe like you've got a network drive on these. That's the network drive is secure. So when I say delete it from the computer, I don't necessarily mean like delete it from the network drive. Just make sure it's not in the root directory of the bloody hard drive. All right? Make sense? All good? Good. That was something I actually only recently found out about. So, let's start up our Apache server. There we go. Go to your htdocs, and as you can see, like, look. Nintendo images. Right? This is clearly and obviously, this is clearly Professor Adams' stuff. These are all the, you might remember assignment 5 from client side, right? There you go. Here's his rogues gallery. So yeah, consider this a public directory. Okay? That could. Thank you, Steve. You couldn't have made my point better if I had asked you to do that. So, let's, what's today? 2025-07-03. Oh, well, that's not correct. Okay, there we go. So, let's get, well, I used to be in the habit of using VS Code for these, but VS Code really doesn't play nicely with apps anywhere, it seems. Like, it'll like crash, but not let you know that it's crashed, and then it just doesn't save things. It's very frustrating. Notepad++ works better, at least for me. You are free and welcome to use any editor that you like. I don't care. You can use Notepad if you like, not even Notepad++. It doesn't do syntax highlighting though, and that's useful. So, if you want to use VS Code, if you want to run the risk, then you're welcome to do so. So, so let's just get something going. So, your sort of minimal example with respect to file I/O was a site counter, right? This is the number of times this website has been visited. Using sessions, we can now change that to, this is the number of times this website has been visited by you, at least for this session. So, oh man, makes me so sad that I'm not doing Node right now. So, PHP is a language of sadness. That's okay, we still have to learn it. So, let's just echo something. Someone's having a good time out there. Echo, you have visited this site n times. Save that, of course, to your htdocs folder. Call it index is fine. Index.php. There we go. Because this is now up and running, we should be able to access it from the browser. So local host 1080 slash 2025-07-03 slash, and that should, yep, oh, yes, true. I didn't define my variable. Find that quick. There you go. You have visited this site 0 times. There you go. So far, not very useful. So, does anybody recall the function that we call in PHP to start a session? It's pretty easy to remember.
Session start.
Session start. So, there's something in the notes about having to put this right at the top of the file because something it writes into the header something else. It actually works if you don't. So yeah. Session start. So session start, you'll notice, has like typically you don't even have to give it anything. It's configurable in a couple of ways. You can set what the name of the cookie is. You can set what the session expiry is. A lot of options like that. We don't necessarily need to go into those details. It works quite well by default. By the way, does anybody know what the default timeout is for a session?
Is there even one? Is there even a default timeout, or is it just 0?
Oh, there is definitely a default timeout. It's 21 minutes. And don't ask me why. But yes. So, session start. Very good. Even just going so far, reloading the page, we can take a look in our application tab and take a look at the cookie that was sent. Aha! PHP session ID. And there is our cookie value. Very good. So we have our session cookie being sent. So far, so good. Any questions so far? Good. So, now of course, we have the small matter of how to actually use a session. So, many of you will probably already be picking up the flavor of PHP by this point in the course. PHP loves super global arrays. Does everything with super global arrays. If you're looking for data, pretty sure it's in a super global array. The session start, creates a new super global array. So within your PHP code, you now have access to session. And because this is, I don't recommend doing this in production code, but this is something you can do to always view the content of your session. Echo JSON encode the session. And maybe like throw in a break. There you go. So this is a very, 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 very helpful debugging tip, right? The thing thing that you need to debug code is information about the state of the program. That is what you need. That will give it to you. Okay? So, we can view the contents of the session superglobal. Very good. But there's nothing in it. We look at the array, and the array should be empty. So, we add things to it the same way that we add things to any other associative array. These are associative arrays and not objects. It's basically the same way that working with Python dictionaries works. Do you guys do dictionaries in Python? Not really. Well, they basically work like these. So, sorry. If we want to say session at test is equal to 7. There we go. Reload. Test gets the value of 7. But what's more interesting, if I remove this line of code and I reload the page, test still has the value of 7. The data inside of the session superglobal is persistent between calls. That's the whole point. That's the whole point of the session, is that the data inside of the session is inside of a database. We are requesting and looking up that data, loading it into our PHP script. That data is persistent, so long as we are accessing this with the same session ID. So let me show you, let me just quickly snatch my session cookie, application cookie, take that cookie value, copy, paste, there you go. That's the session cookie that I just created, right? Now let's break the session. Delete the cookie. That breaks the session. If I reload the page, you can see that data is gone. And if you take a look, we have a new session cookie with a new session cookie value. Ta-da! A new string. Brand new session. What happens if I take this, put it in there, restore the session ID that we had previously saved? I get back to my old session. Right? XAMPP only communicates with the local host, and it can't tell what it's communicating with. Honestly though, like, I could be doing this from multiple different browsers, which would give the effect of being multiple different clients on one machine. Yes?
21 minutes later, that would not give you test 7.
Correct.
Okay.
Yeah. So both of these cookies will expire in 21 minutes. Well, 19 minutes, whatever. Once they do, the data associated with the session is deleted. It's gone. It's not persistent past that point. It's not meant to be. Does anybody know what we use if we want data like this to be persistent past 21 minutes? What do we use? Sorry?
Timeout?
No, not a timeout.
That's it.
It's the subject of next week's class. Databases.
Oh.
Right? If we want long-term data storage, we have a solution for that. It's called a database, right? When I say that the session database, like when I say session database, I'm not talking about an SQL database, right? It's like a little mini one that the server contains inside of the web server, right? When you're talking about big data, when you're talking about long-term storage, you are actually talking about another server process. Databases are their own servers. They're different from web servers. We'll talk about that next week. But if you want long-term data storage, this is not your solution. Make sense? Good. So let's now implement our counter.
So,
Oh yes, question.
so when we save like a previous session ID,
Mhm.
and then is this why hackers have to work so quickly so that the 21-minute timer doesn't time out on them while they're trying to steal the information?
Yes, this is why hackers will work quickly, but it's also the reason that, like if you're a hacker worth anything, you're not doing things by hand, right? You've written scripts to do these operations very quickly, right? Hackers are like quite good at from what I've heard, I've never actually talked to a hacker, but this is what I hear about hackers. They're quite good at coming right up to known timeout values, doing as much damage as they can do before the timeout, like get in, yeah. They'll do things like play with the expiry latency on an HTTP packet. It's like, okay, I know that the server is gonna wait for this packet for 2 minutes. I've got 2 minutes to modify this packet, then I can send it back to the server. Stuff like that, right? But yeah, there are, and we'll get into this a little bit more when we talk about login sessions and login security. One of the security things that you should do if you're, a server programmer, you don't you refresh your cookie values, right? There's a session, I think it's called session refresh. Regenerate ID, that's it. Session regenerate ID does exactly what it says it does. It generates a new session ID and sends that to the client. It requires the client, clients are still always initiating communication, but your best case scenario for security is you regenerate the ID every time they send you a packet, right? If your client is sending a packet back to the server every 30 seconds, that means you get a new ID every 30 seconds, right? That's good security practice. Did you have a question?
Yes, is that similar to when there's a two-factor authentication, there's a 30-second time window?
Yeah, so it's kind of interesting. Anybody on GitHub? Yeah? Have you noticed that GitHub now has a pop-up that says, maybe don't use cell phones for two-factor authentication? It's kind of a side tangent, but here's a question. How does a cell phone tower communicate information to your cell phone? It doesn't have a directionalized little dish that homes in on your location and beams information at you. It broadcasts it. When you receive a two-factor authentication code by SMS, it has been broadcast via radio frequency to an area of how many square kilometers? Right? So that's why they don't like SMS. But yes, that's the same idea, right? It's when we issue when we issue a security token, we want it to expire as quickly as possible, while still being useful, right? 30 seconds should be enough time for the average person to find their phone, open it up, and look at their messages, right? On the outside. I have, about the cheapest, most terrible phone in the entire planet, so it takes me about that long, right? But yeah, like, if you're listening to cellular transmissions, right, then you're getting all of everybody's security codes that are being broadcast, right? Which means you could, in theory, use them if you had enough information. It takes a little bit more than just that, though, and it's a lot more difficult to suss out what the codes are from the rest of the data, and it's a complicated thing. I wouldn't expect, I would expect a security services agency to be able to do something like that. I wouldn't expect your bedroom hacker to be able to do that, right? But, so it goes. Sound good? Any other questions? Okay. So, and if you feel like you need a couple of passes at sessions, we're basically going to be doing them for most of the rest of the course. So you will see these quite frequently going forward. Okay? You'll have plenty of opportunity to review them. So our object, the thing we are trying to accomplish, is to get this counter to increase inside of the session. This means that fundamentally, n is no longer just a plain old simple variable. It is now what we call a session variable. It's not really a variable in a technical sense. It's an element of an associative array, but it works like a variable, so we call it a variable, right? But fundamentally what you're doing is you're saying session at n is equal to 0 instead of that, right? Then, of course, you have to modify this. Session at n. Of course, that's a little tricky using string insertion in PHP. So I think, if I recall, you can break it out with curly braces. Is that right? Yeah, curly braces work. Which is kind of the same way that format, the format thing that they added to JavaScript works as well. So far, so good. So the next question then is, how do we keep this up to date? Well, essentially, every time we want to load this page, we want to increase the value of n. So perhaps it would be as simple as saying n++, right? I forget, PHP has ++, right?
Yeah.
Which one is it that I'm thinking of that doesn't? Might be Python. Oh, bloody Python. All right. So, let's take a look. See if this works. 1. Oh! Looks like we have a bug. No matter how many times I reload the page, all I get is 1. So let's take a look at our code. Can anyone see the problem? Yes, sir.
We're signing N0 every time.
Yeah.
Yes, on line 4, we're writing n is equal to 0 every single time. We increment it by 1, we always get 1. So, this is a very important thing when working with session variables. When you write your PHP script, you must always consider 2 cases. One is a fresh session, and 2 is a session that already has the variables in it. So, does anybody know of a PHP function we can use to tell if a superglobal has a particular element in it?
Is set.
Is set. Very good. If is set session. N. Else. One of these belongs in one of them, and the other belongs in the other. If n is set, then we know that the variable is already initialized. So, we put the line where we modify it there. Otherwise, we want to initialize the value. Does that make sense? Good, good? There we go. Save. Now, so it goes. I can delete the cookie, resets n to 0, we have a separate counter. And that is how a session works. Any questions? Okay. I hope that I hope you folks find this fairly straightforward. It's, you know, of our second half topics in this course, this is like probably the easiest in terms of getting like a minimal code example working. So, sound good? Wonderful. So, now that we've placed data into a session, we should talk a little bit about when and how the data gets sent, like how the server deals with the data, right? So, session start looks up the database, pulls the database information, stores it in the superglobal. In order to have any changes take effect for the next round, any changes you make to the session superglobal must be saved. They must be stored. By default, with PHP, this happens once the script has terminated. One of the things it does as its shutdown routine, its closeout routine, is it takes the session superglobal that we have modified and written to, it takes this guy, and like, say, about here, it writes it back into the database, saving the data that you've modified. Does that make sense? So, the The consequence of that, of course, is that if somehow you manage to have certain types of bugs occur, I think most particularly an infinite loop would probably do this. If you're stuck inside of an infinite loop and it just like crashes the server or whatever, you won't have reached the bottom, so any data that's in the session would be lost. Makes sense, right? You're not getting to the point where you write that data back into the database. Sound good? So let's talk about a few additional important session functions. All right. Also, I have one thing about the notes which is important for me to do. You will find just kind of the flavor of this class and me teaching it. An unfortunate percentage of the time, if I actually have the course notes open, I'm pointing out an error in them. So I like to teach from the blackboard, or the whiteboard, whatever color this board is. That's what I like. So there's this section on ending a session. All right, it recommends 3 different approaches. You can overwrite the session superglobal. This is true and this works, right? But you are relying on that change being written to the session database once the PHP script stops, right? So you're basically just overwriting all of the data in there, blowing it out, and saying, well, I hope this gets saved, right? It would be better if we, if we want to destroy session data, it would be better to also have that take effect in the database itself when we ask it to, right? So that's not as good an approach, right? In particular, I can think of several scenarios where that would be a problem. Consider this. What if you are, you make a request to a PHP script and it's taking a while because it has to talk to a database and the database is like in Denmark or something and it's just taking a while, right? There's a latency. Someone else comes along with the same session ID. You think you've deleted the session, but it hasn't been deleted until the script finishes. It isn't deleted until you've heard back from Denmark, right? Somebody goes in, all your data is still there, they get your data, off they go, right? Delete should mean delete, right? It should mean delete as soon as I say delete. That being said, it does technically work. Now, the question now becomes, session unset or session destroy? Now, you might be inclined, if you're a dramatic person, you might be inclined to say, well, obviously what I want for my data is ultimate destruction. I want it dead, deceased, pushing up the daisies, kicking the bucket. I want it no longer existing. Not just unset. I want it destroyed. But we should check the documentation. php.net. Let's see what it says when we look up session _ destroy. Oh, wait, that was cool too. So abort is end the session without writing changes, right? That could be useful in circumstances. But let's talk about session destroy. Session destroy destroys all of the data associated with the current session. does not unset any of the global variables associated with the session or unset the session cookie. To use the session variable again, session start has to be called. Warning! Immediate session deletion may cause unwanted results. When there are concurrent requests, other connections may see sudden session data loss. Although current session modules does not accept empty session ID cookie, they've actually updated that since the last time I saw it, but basically they would prefer you didn't use it. Like, PHP itself is like, consider what you're doing before you do this, right? Yeah, they've actually updated this. It used to say basically just don't use this, use session on set, which seems to be pretty good advice. So, session unset, there you go. There you can see, no great big warning box on session unset. Freeze all session variables currently registered. So the difference between session destroy and session unset, session destroy deletes all of the data and also deallocates that entry in the database. It removes the database entry entirely. It invalidates the session cookie, right? Session unset leaves the cookie alone, but it deletes all of the data associated with the cookie, right? So, you know, the unfortunate case is like when they talk in the previous here, in the previous box, when they talk about concurrent requests, this is generally like the direction the internet is heading, right? So, does anybody know what an API is? Application Programming Interface, yes. Does anybody, so API, you will find, is a term so general as to be almost meaningless, right? HTTP itself is an API. The collection of public Java methods is an API, right? What we're talking about, like when the word API is used in a web context, most of the time they are talking about RESTful APIs or REST APIs. Sometimes they just call them web APIs, which is, you know, it would be nice if we could agree upon a term for this, right? But the general idea behind an API, we are no longer thinking about the internet as issuing web pages. We are no longer thinking of the internet as one great big distributed file system, which is how it started. We are now thinking of internet traffic as being closer to a function call, right? We are now thinking about HTTP packets as if they were function calls. That is the idea behind the API, right? So, generally speaking, you can tell whether something was an API request by the type of data it's returning, right? If you're getting HTML back in your response, then it's just a standard packet. If you're getting something like JSON data or CSV data, then that was an API call, probably. Do you have a question?
No.
Oh. Oh man. Oh, I forget the website. But I was reading a blog thing, and I was reading a blog post about I think it was Cloudflare. Let me see if I can find it. something like this. Landscape of API traffic, something, 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 something. Yeah, here we go. So this data is quite old. It's like 4 years old. By the way, this is from Cloudflare, and by the way, the way that they have this information is by spying on all of the people who send packets through their service. Never mind that though. So this is looking over the year 2021. You can see that this yellow bar is API traffic with respect to all, like, as compared to all other forms of internet traffic, right? So APIs, general web, that would be HTML, CSS, JavaScript. Media, sound, music, video. Other, who knows, plain text, probably also API. And then actual binary data, you know, like PDFs and executables and that sort of thing, right? Within 1 year, that was the growth, 4 years ago. If you ask the same question today, it's something like 75% of all internet traffic. 75% of all internet traffic, with several exclamation points, is API calls. Right? Now, like, web will never go away, right? It's always you're always going to need to load a web page, right? Because it's web pages that are loading all of these API calls, right? But let me ask you, when you ask ChatGPT something, what's that? That's an API call, right? When you're doom scrolling through Twitter, what's that? That's an API call, right? APIs, again, the term is very, like, loosely defined. Basically, in this survey, they're determining API by, like, JSON, CSV, kind of like YAML, loose data formats, because they don't really know that these are APIs. They're just looking at, like, the data type of the returned result of the packet, right? But you know, that's probably a good enough approximation. When you have a website that is making API calls, do you think it's only making one type? Probably not, right? You have no idea how much API traffic is occurring if you're simply browsing Facebook, right? The obvious one is, when I get to the end of my feed, load more stuff into my feed, right? Or near the end of my feed. But there's likely a whole host of other things, tracking things, advertising calls that are being made in the back end that you have no idea about, right? So when the PHP documentation is telling you session destroy isn't great because it interferes with multiple simultaneous concurrent calls to your program, calls to your server, API is what they're concerned about, and that's the majority of internet traffic these days. So we no longer have the luxury of imagining that's not important, right? Concurrency is very important. So session destroy, like, it's not really a viable option. You should forget that you know about it. Even though the name is dramatic, you should just use session unset for everything. Does that make sense? Have I convinced you? Have I made a convincing argument? So when you are looking at the output of a certain accursed chatbot and it's putting session destroy in things for you, you know what to do about that, right? Change it, right? Yeah, anyway. Well, that's about all the time I have for class today. Thank you very much for your time and attention, folks. I think we meet on Mondays as well, is that true?
Yep.
Yeah.
Can you just show the code again?
Oh, yeah, sure. I'll also post the code to the announcements feed. Yeah. I actually, I got from the winter, on my winter course evaluations, I got a commenter that said the only good thing about this course is that they post the code to the announcements feed. So I'm probably going to keep doing that. You know, I respond to feedback. So,
Thank you, I was missing the underscore beside session.
that's how they get you. It's always something like that. All right, thank you very much. Class is dismissed.